Hey folks, so I had a really good question about homework problems section 10.5, numbers 14 and 15, and that they are both quite challenging. So just hang with me. I'll do my best to explain how to calculate the answer and how to answer their particular questions as well. So on number 14, it says, in a 5-card poker, a straight consists of 5 cards of consecutive denomination, with the cards not all being the same suit. Verify that there are 10,200 ways to get a straight. Now, y'all, I struggle sometimes when they want to help me prove something like these questions. They're not asking you to just come up with the answer. The answer is 10,200, but they're trying to talk us through getting the answer. And again, I struggle with that, as I'm sure you do too, because these questions are really difficult. Plus, the way they ask things can get challenging too. I did find number 14 very helpful, the way they ask the questions. And first, on a blank page, I just want to explain what a straight is. I mean, it tells us a straight consists of 5 cards of consecutive denominations. You know, denominations are like the numbers, like a 2, 3, 4, 5, 6. 5 cards, or a 7, 8, 9, 10, Jack, Queen. So what I'd like to do is list all the possibilities before we even get too far into this problem, and I'm doing that on the next page. So let's just think about the lowest possible number that we could have. And when I think about that, really it can be an ace. An ace can be, it says on the first question actually, that an ace can be low or high. So I'm starting with like an ace is a 1, so we could have an ace, 2, 3, 4, 5. So that's one option. Then you could also move on up a little bit. Then you could have a 2, 3, 4, 5, 6, right? And I'm doing this systematically, so I'm trying to be really organized about this. I could have a 3, 4, 5, 6, 7. Notice I'm doing 5 cards every time. Or I could have a 4, 5, 6, 7, 8. Or I could have a 5, 6, 7, 8, 9. Or I could have a 6, 7, 8, 9, 10. I know this is getting old, I apologize. A 7, 8, 9, 10. Now it's not an 11, right? It's a jack when you're playing cards. And then an 8, 9, 10, jack. And then a queen comes after a jack. And then a 9, 10, jack. I put a K, it should be a queen. I think I said queen, but I sure didn't write it. Queen, and then jack, queen, king, and then the last possibility is you could have a 10, a jack, a queen, a king, and an ace. And I know all too well, this problem's hard for everybody, but people that have never played with a deck of cards at all and struggle to understand what's in a deck, this is extremely difficult just to think through this. But let's go back to our question list. So this is all the possibilities of just the denominations. Now this has nothing to do with the suits or where the cards are coming from. This is just the denominations. So you have an ace through 5, or 2 through 6, or 3 through 7. I won't do it all the way down, but you see what's going on. Now let's look at the first question they ask us. It says, if an ace can rank either below a 2, so we called it a 1, or above a king, okay, there are A equals how many ways to pick 5 consecutive denominations. And that's what we just wrote down. So we're going to count how many ways we can do this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 different ways. Okay, so I can't really fit my 10 in that little square. So there are 10 different ways to do a straight, which is 5 consecutive cards. Okay, now it says for now, disregard whether or not the 5 cards are all the same suit. Okay, because remember, they can't be all the same suit to have what is defined to be a straight. But we're just going to ignore that for now because it makes it easier. For now, disregard whether or not the 5 cards are all the same suit. For each of the 5 cards, there are how many ways to pick the suit. By the way, let's keep up with what we call these things too. So this is 10, and they call that A. So it says it right there in the problem. Now, what we're about to find now is B. Now, how many ways can you pick a suit? Well, there are 4 suits for every denomination. So the answer to this is 4, and they're calling that the variable B. Now, next, it says this means if the cards may not all be the same suit, there are C equals, and then there's a blank, equals another blank. So they're wanting us to use variables here. Now let's think about this. Okay, so we have that 10 to start with. So there are 10 ways, first of all, to create those list of 5 cards in order. And then for each of those 5 cards, there's 4 ways to pick the suit that it comes from. So say, for instance, if we go back to this first one on the list right here, okay, with an A first, 2, 3, 4, 5. So this ace, there's 4 ways to pick that because there are 4 different denominations. There's 4 ways to pick the 2 because there's 4 different denominations, or 4 different suits. So let me say this correctly. There are 4 ways to pick the 3 because there are 4 suits. So there are 4 3s, there are 4 4s, and there are 4 5s. So if I go back to this and I write this, really what's going on is we have, let me get my pen working again, 4 ways to pick the first number. I'm going to try to confuse you here. I'm really trying not to. 4 ways to pick the first number. 4 ways to pick the second number. 4 ways to pick the third number. 4 ways to pick the fourth number. And 4 ways to pick the fifth number. Right? So really what that gives us, if I write it below here, although I'm not into that next question, it's 10 times 4 to the 5th. Okay, but really they're calling that A. Let me write it here because 10 is A. So that's A times B to the 5th. Right? Now, see, that's what's not natural about this problem to me. It's hard to understand the way they're trying to get you to answer the question. So I know why people need help on this problem. All right? And then they want us to calculate it. So what is 10 times 4 to the 5th? I'm pulling out my trusty calculator. I'm going to type it in. So 10 times 4, hit my exponent button to the 5th, and that gives me 10,240. So far our calculation is we have 10 ways we can build this straight, and for each of those 5 numbers there's 4 different ways we can pick what suit that denomination comes from, and that gives us 10,240. Now, next line, it says the cards in a straight are not all the same suit. However, it is simpler to consider the cards all being the same suit. For each of the ways to pick 5 consecutive denominations, there are D equals how many ways for the cards to be all the same suit. Okay, well, so we're going back to look at this list, and they're trying to say how many ways can this list right here be all diamonds, or all hearts, or all spades, or all, what have I left out? Anyway, clubs. Okay, how many ways is that? There's 4 ways to make them all the same suit. So the answer to that particular question is 4. So this one right here is 4. Are they calling that a letter? Okay. How many ways could be all the same suit? 4. Let's see. They're not calling that anything. This means that there are E equals. Okay, so this next variable is going to be E equals. Okay. And it's going to be A times, my bad, they did call that something. That's D equals 4. Can this problem really be any more confusing? Again, I know why you asked this, and I don't put this on the test because it's terrible. Okay, so D equals 4. When we go back to this calculation, I don't think about it as A times D. That's what they want right here is A times D. I think about it as 10 times 4 equals 40 ways that they're all the same suit. But remember, we're trying not to count those. We're trying to eliminate those. Okay, so they call that E, which is 40. Finally, in the last question, so where's the 10,200 coming from? Well, notice the total we got earlier was 10,240. I'm just trying to write 10,240. And we're subtracting out all the ways that they could be the same suit. So I'm subtracting out that 40, which is going to give me 10,200, which is the answer to the question. Now, they have all these options here, but notice what we actually did is we did, what did we call that? C is 10,240. I can't keep up with these variables. C is 10,240. So we did C minus E to get 10,240, and there it is right there. And again, don't panic. I think these are interesting questions when they're homework, although they will give you a big old headache, but I don't put anything like this on the test. So really the battle is just to get through the homework question. Okay, now let's talk about the next problem. Okay, problem 15 in section 10.5, we've got a 5-card poker again, so you know it's going to be a challenging problem. 3 of a kind consists of 3 cards of one denomination plus 2 cards of 2 additional denominations. Verify that there are 54,912 ways to get 3 of a kind. Now this problem, when I first did it, I just did it on my own without looking at, because I really get confused with the way they ask these questions. I know you do too. So what I want to do is just kind of talk about it and then see if we can translate that back into the way they're asking these questions. Okay, so again, we're dealing with 5 cards to start with. They want to know in how many ways. We actually know the answer, 54,912, but with 3 of a kind. Now, let's just talk about what in the world is 3 of a kind, okay? So 3 of a kind means you have 3 cards that match. Let's just say we have 3 9s. I don't want to look like this is multiplying. So 3 9s. These are cards I'm drawing. And then 2 different cards. So say, for instance, an ace and a 6. That's an example of 3 of a kind. Now, we know there's like 54,000 plus of these, so it's not like we're going to list all the possibilities. This is just not going to happen. But I put this example here to help us just think through how we could possibly do this. So let's first of all think about how in the world we could pick 3 cards of the same denomination. Okay? Now, you know, each number, okay, or denomination has 4 different suits you could pick from. So let's think about how many denominations there are. First of all, there's, you know this, right? There's 13 different denominations. So if we count them, you start with an ace, and then there's 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. So if you counted those, there's 13. So first you got to pick what denomination you could possibly use. So that's going to be a combination of, there's 13, and we're just picking 1. So let's just say this is a 9 of hearts. They can't all be hearts, right? So a 9 of hearts, a 9 of diamonds, and a 9 of clubs. And I can't draw clubs, so I'm just going to put a little spot there. Okay, not quickly anyway. So 13, choose 1. But then we've got to pick 3 of those 9s. Now, how many 9s are in the pile? Well, there's 4, right? 1 heart, 1 diamond, 1 club, 1 spade. So we have a combination of 4, choose 1. This alone picks the 3 of a kind. So you're picking, first of all, a denomination. Do you want 9s or aces or kings or queens? That's what we're doing first. And then we're picking 3 of those cards. Forgive my mistake. 3 of those cards. Not 1 of them. Now it's right. It was not right before. Okay, so picking, first of all, the denomination. Second of all, out of those 4, we're picking 3. Now we've got to address these 2 guys over here. Okay, now it says specifically that they have to be different denominations than the 3 of a kind, because if it was the same, it'd give you 4 of a kind, right? So that doesn't count. And they have to be different from each other, too. So let's go back to our picking here. We picked a combination of 13, choose 1 to pick the denomination for our 3 of a kind. Well, if we've picked one of them, 9s in this case, then we only have 12 left to choose, and we're picking 2 of them. Okay? The reason we're choosing 2 is because these cards cannot be the same denomination. So I can't have an ace and an ace, or a 6 and a 6. Because that would be called a full house, and that's not the same thing as 3 of a kind. So I'm doing a combination of 12, choose 2. And then finally, just like after we picked the denomination and we had 4 cards when we were picking 3 of them, think about it this way. I'm picking the denomination. My pen working again. Okay, this is one of them. I have 4 cards, I'm choosing 1, and then I have another 4 cards and I'm choosing 1. So like for the ace, okay, there's 4 aces, I'm just picking one of them, and then for the 6, there's 4 sixes and I'm just picking one of them. And then if you multiply all this together, y'all, you're going to get the answer. We could check it, 54,912. Now, notice I have not answered any of the questions on the problem. Okay, so we're going to go back and use this information to see if we can answer the questions the way they want them. And sometimes the way they ask things helps me, like on the first problem we did, number 14, but this one I just did better to do the problem by myself and go back and look at the way they ask the questions. Okay, so let's go back and look and use this information. So I'm going to be flipping back and forth between pages. All right, so first, consider the 3 cards of the same denomination. There are A equals, so I'm going to make sure I use my variable again because that's where they really confuse me, equals how many ways to pick the denomination of the 3 cards? Well, there's 13. That's that combination of 13 choose 1 that I had. So the answer to this question, this first one, is definitely 13. Okay, so for each of the A ways to pick the denomination of the 3 cards, okay, which is 13, there are B equals, we're about to calculate B, okay, they want us to use a formula first, okay, and then this is going to be that combination of 4 choose 3. So remember back on our problem here, 4 choose 3 right here. So this is the 13, choose 1, which is actually 13, times the combination of 4 choose 3, and then we need to calculate what 4 choose 3 actually is, and 4 is 4. Okay, so make sure I'm putting things in the right place. That second block is 4, which means B is actually 4. Okay, so this means there are C equals, okay, A times B, which is 13 times 4, which is 52 ways to pick 3 cards of the same denomination. Okay, so if I go back to my calculation, all they're doing is calculating, so let's keep this purple, they're calculating this part. Okay, so combination of 13 choose 1, which is picking the denomination, times the combination of 4 choose 3, which is picking the 3 cards out of that particular denomination, which is 4, and 13 times 4 is 52. That's where we are now. So they're going to ask about this stuff at the end next. All right, and by the way, 52 is the variable C. And this is where I lose my mind with all this variable stuff thrown in. Okay, now suppose the 3 cards of the same denomination have already been picked, and consider the remaining 2 cards. There are D equals, okay, if we go back and look at our calculation, remember to pick those 2 cards, the first thing is we picked the different denominations, which is the different numbers, or Jack, Queen, King, that sort of thing. So that's that 12 choose 2. Okay, so they're calling that D, and again we're going to type in combination of 12 choose 2, which 12 choose 2 is equal to 66. So they're calling that D. So D is equal to 66. So now we've got A, B, C, and here's D over here at 66. Okay. Now it says for each of the remaining 2 cards, there are E equals blank ways to pick the card once the denomination is picked. So remember, we're picking 2 different denominations, and there are 4 suits. So for every denomination, you have 4 different ways you can pick it. So here they want E equals 4. We did that in the last problem also. This means that after the 3 cards of the same denomination have been picked, there are F equals, okay, and then they want us to do 66 times 4 twice. If they do that in variables, that would be 66 was our variable D times, and then E to the second. So that's what should go in that first block. D times E to the second, and we've multiplied 66 times 4 squared. We get 10,056. So that goes in that second block. So this block right here is D times E squared, and this block right here is 10,056. Can it be any more confusing? Okay, and then the last, it says there are 54,912 ways to get 3 of a kind, because which of the following is true? Basically, we multiplied all that mess together. Okay, so the first way, was that not C, which is 13 times 4, times D times E squared, so that'd be C times F? Yeah, my goodness. Okay, how about that? C times F, which is 54,912. Because this is so confusing, this part. They called all of that C. Oh, bad, I don't have my pen working. They called all of this C, and they called all of this F. So if we go back, that's just going to be C times F equals 54,912. Now, there is a similar problem to this on the practice test and the test. It is not as challenging as this one, but you do have to deal with this idea of, say, picking a denomination or picking a suit first times the calculation, but it's not as rough as these two problems. Okay, I hope this helped. I'm sorry if it was confusing. It really just is a confusing way to ask the questions. But if you have any more questions about it, please do let me know. Have a great day.